here in Slack, we've got the following app for pandas. And the idea here is to go ahead and modify this. Right now, you can pull a bunch of variables in the chart updates. And if you go to the code on GitHub, the idea is that you go to app.py and you would update specifically line 51. Yeah, thank you very much. Line 51, which is a group by statement so that it does something other than cabin, class, and embarked. That's what we're looking for. And it looks like some people have already selected out their results. Like Sylvie. What'd you do, Sylvie?
Died, lived. I just changed the...
Died versus lived. Excellent.
And then because died, lived is a derivative of the survived, I took out the survived.
You removed survived. Excellent.
And added the died to the line 23 that you implied. So.
Excellent. Thank you. That's what I was hoping for.
If, for example, I would want to chart with age groups or parent groups.
Yeah. You would have to create those.
Create, right?
Yeah.
In the app file, right? So
either in the app file or in the underlying data file, one of the two. You could do it in the data file itself before opening it up in app.py, and that would also work.
Okay.
Yeah. Oftentimes, that's sort of one-time data manipulation. You want to get as much of it out of the way as possible so you don't have to reinvent the wheel every time your app opens up. Because otherwise, every time someone fires up your app, it reads in the raw data, creates all the new categories.
But I need
right?
to save the data set in place.
Yes,
right?
you would.
Okay.
Exactly.
Otherwise, it would call in your library and the type in. Oh, okay.
Exactly.
No, okay, now I get it.
You could save it in your assets file or something like that.
Yep.
So an address is used when we're close it out.
Just a quick shout out. Folks are actually working on the Plotly Dash example, right? Yeah? Because if you're not, I'd like to know because I'm going to dive into something else. But if you...
I'm still working.
You're still working on it? Okay. All right.
Yeah.
All right.
Yeah, remember, like on the app.py just told me that the app is already used and I got all my windows closed.
Probably that means that it's running locally on your machine in that same port. Do you have any terminal windows that are still open? Yeah, I'll bet you've got a terminal that's still running in that port. All right, 5 minutes. Hey, okay, how's it going? All right, so let's go ahead and take a look at a few of the other ones that came out. We've got, well, Isaac, I guess, is the only one else, the other one that's got it here. We got for us Isaac. So we've got, you've got cabin class by survival, fare, and age. Okay, great. And I'm going to take a look at your code and with your app. Down here at line 51, line 52 in yours, we've got cabin class and sex by continuous variable. But your list of continuous variables is now survived, fare, and age. Excellent. Okay. So like similar to Sylvia, you've reduced it down to 3. All right, let me talk a little bit about what is going on in the original app. And I'll kill the light. Actually, can you get the lights? At least the front row. Yeah, thanks. Is that good enough? Grace, can you see that okay? Yeah, okay. All right, so we've got our imports. There's a lot of dash going on in this one. We set up our data frame as usual. And then there's a number of pandas items that are going on here, which you frankly could have done most of this in a Jupyter notebook and simply linked to a different CSV file. As you can see, I'm reading in from my own GitHub profile. So we're remapping female so that instead of a text variable, it's a 0 and 1. We're remapping cabin class so that instead of a numeric variable, it's an alpha variable. And then we have this list of categorical variables. Survival, no, actually, I'm sorry, they're a list of continuous variables. Survival, female, fare, and age. The rest of the app is pretty straightforward. We have a drop-down with options like we've done before. I will give a quick shout out here at line 29. This is an example of what's known as dictionary comprehension. It's the first cousin of list comprehension. A different way that you've seen this written out up until now is to say that options is equal to a list of label, and then in variables list was survived, value, survived, and then so on for the rest of it. And this would all be a dictionary, not a list. So this would all be a dictionary, and you would have seen 4 different dictionaries for each one of the variables. Something kind of like this, but instead of survived, it would have been female, fare, and age. But you can do it, all of this, what I've done here in 4 lines of code, you can do it in a single line of code in line 29 using dictionary comprehension. I'm not going to go into the nuts and bolts of that right now, but it's kind of a nice shorthand and the sign of a very efficient coder if you're able to reduce the number of dictionaries that you write from 4 down to 1. But the idea here is that this is the drop-down, and these are the options that the individual chooses from. The output goes into value, which then in turn gets fed into the input of the callback. And that value becomes renamed continuous var, which in turn gets called here in the group by statement. So depending on what they select, the group by is calculated differently depending on the continuous variable chosen. Once the data set, or data frame rather, of results is calculated in line 46, everything else is static. It's just a standard paired bar chart. My data 1, my data 2, my data 3. The only thing that's changing here is, once again, continuous var is the input of the function, which corresponds to the value of the callback, which in turn corresponds to the value of the dropdown. That's why the figure updates each time, and the rest is static. All of this gets output into a figure, so the return statement returns the fig, which then feeds back to the output of the callback, which then in turn feeds into the display value ID of DCC graph. Okay, so this is similar to what we've done before with other callbacks. The only difference is this is combining our pandas knowledge with our plotly-callbacks knowledge. That's what's new here. We've seen a lot of callbacks at this point, and we've seen a lot of pandas. This app marries the two of them into a pandas-style callback. And my hope is that you would be able at this point to write something pretty similar to this on your own for your final project. And that would be a great addition to have. Anybody have any questions about this or things they'd like to see in a little more detail about this particular app? Isaac.
I guess there's a question. So my original thought when I was doing this was to just swap and mark all the options and drop down.
Right.
And I did that.
So swap embarked for one of the options in the drop-down. So right now it would be female, and over here it would be fair, and then embarked would be the last one, right? And you would have done the same thing for that label as well. Something similar to that, is that what you're thinking?
Well, I just switched it in the variables list because we were still doing the dictionary.
Okay, sure. So just get rid of all this because I'm just going to screw everything up if I do that. Bring back the dictionary comprehension, and instead of age, replace with embarked. And that did not work.
Actually,
Can you-
replace female with a mark.
Okay. And was that the only initial change you made? Did you make any changes to line 41? Because the reason why that won't work is because you're grouping on embarked.
Female there.
Oh, you put female here. I see. Okay. Okay.
And it was, because mark didn't update.
My guess, the reason for that is because the other three are all continuous variables, but embarked is a categorical variable.
So why did the female?
Because female is a 0-1. It's actually continuous. Because we recoded it here at line 19, right? Keep in mind that in a group by statement, you can't take the mean of an alphanumeric categorical variable.
Okay, so would it be to recode that similar to how?
Yeah, to a 1, 2, 3 perhaps. Yeah. So at the same time, you'd have to stop and think, what does the average port of embarkation mean? What would a 1.5 mean? It would be halfway between Southampton and Queenstown, which actually is not a logical value, right? Other questions about this app? Anybody?
If we would want to show some prediction, so let's say it's not variables, but like equal model parameters. That
At what line? Give me a line.
So for example, in 19 or 20,
Yeah.
that would be the pickled my model parameters.
Yes.
Then would that work in a callback later?
So you would like for your user to choose parameters of your model?
Yes, for example, it would choose that results from model 1 and then model 2, model 3. Three different predictions.
So that's an excellent question. We did actually see something similar to that with this guy right here. If you remember the one we saw last week where you could choose the iris,
Yeah.
and we saw classification of iris flowers. In fact, I'm actually going to pull up the entire app here. It would have been and this guy. So this is what the final app looked like, right? And you can choose the length of the sepal, and you can choose the length of the petal, and this is taking a second, and then you can choose the number of neighbors, right?
Yeah.
Number of neighbors is a model parameter, right?
Yes. Yeah,
It's
that's
definitely a model
right.
parameter. Yeah, so that's definitely what's going on here is you have the chance to choose that.
Okay.
And the way that looks in the code is here. So they get to choose the K-drop. That's one of the drop-down values, which in turn selects which of the 5 pickled models get displayed. So the pickling code or the unpickling code is actually inside the callback. So what you have to do is you can't actually allow them to rerun the model.
Yeah,
That wouldn't work.
No.
You have to run the model yourself with all possible variations of the hyperparameters, pickle each one of those models, and then allow them to choose the model from the pre-selected list of parameters. Which is why, in my model, I don't allow them to choose any number of neighbors. They can't choose 67 neighbors, right?
Yeah,
I gave them 5 options. And that's definitely a more doable approach. Okay. All right. Good. Good. Well, I think that's pretty productive. As I said in the Slack message, we've only got 4 more classes, right? On Monday, October 21st, which is 2 weeks from today, you'll be presenting your final models here in front of the class, and that will take the entire class. My hope is that everybody can take 10 or even, well, how many of us are here? I can't really do 15 minutes, but with a 3-hour class, we can do about 10 minutes per person. And then you come up in front of the class, you show us your code, and you show us a working Plotly Dash app deployed on Heroku that makes some kind of predictive analysis of your data set. And then you walk us through the code and you kind of show us what you learned. I do think that this iris classifier is a good template to work from. The one that we did tonight, the Titanic one, it doesn't do any predictive modeling, but I would actually totally accept this as a final project because it does show strong dominion of pandas and of Plotly Dash. And then the third one, which I think I shared with you guys a while back, this Titanic classifier is actually the most complicated of the ones I put together, but also very similar. Allows you to choose the different elements of a person boarding the Titanic, and then the probability of survival is the output. That's also a really good example of what to do as a final project. So any of those 3 would be definitely a strong template to work from. This particular one, the Titanic one? So
This is on your
I can share this again. I shared it a while back. I do actually have a link here to the code on GitHub. Here, I'll Slack this out right now. Yeah. And if I can get my act together and stop being such a slacker, I'll actually put together one more example by the end of the week. Titanic classifier is here. Give me some feedback. How are you guys feeling about the final project at this point? I know that several of you have started. I've heard from Yaolin, I've heard from German, I've heard from Sylvia. Final project-wise, how are we feeling?
I think my issue is also getting that formatted the way I want it.
Yeah.
Guys get to that. Once I get to that, everything will fall into place.
Okay. But it sounds like from our conversations that you're pretty well on track towards making that happen.
But I will go with one instead of trying to do it for all at the same time and see how that works out.
Yeah. Very cool.
I think the difficulty would be how I know it's on the Heroku app. But
But you've had experience with Heroku with these other apps, right?
Yeah, but I'm not sure.
That's crazy.
I'm gonna do it this
Oh,
way.
I would hate you.
Okay.
But I think it will be difficult.
Okay. All right. Well, let me know if there's anything I can do to help. Okay. Others?
Just like making sure I like understand the concepts.
Yeah.
So yeah, I think I just have to do some self-study on the concepts. I think flatly, because I have coding experience, I can kind of find my way around that.
Good.
So it's more so the machine learning stuff, like the predictive analysis stuff that I'm having problems with. Like, just understanding. I understand from a high level what we're doing with like pioneers and things of that sort, but just implementing it in an actionable way to the app, like implementing that and finding like an example that will coincide with that example.
Yeah.
But I just have to, I don't think there's anything as far as, I guess you've helped me enough as far as like understanding the concept. It's just for me to like do some self-study and really get it down pat.
And at a certain point, it's just putting in the hours, which we've all been through totally. Here's a question though for you and for the whole class. At this point, I was kind of thinking to start, it might be useful to dedicate some time in class for you to work on your projects while I circulate and I do some one-on, like not the whole class, but maybe 45 minutes of the class in place of additional Plotly Dash apps. Would that be useful?
Yeah.
Yeah?
Yeah.
Okay.
So are we
Yeah.
doing neural networks in this class?
So Alex, I'm going to be straightforward. When we kicked this off, I was really hoping to get there. And it's definitely in the textbook that I provided you. He has some really strong neural net examples. I did feel that in order to actually hit that milestone, I would have had to really bulldoze through a lot of preliminary concepts. And at a certain point, as an instructor, I made the call that that actually was not beneficial to the class. I have sat through classes where the instructor meets a timetable come hell or high water, and that was not useful to me as a student.
Okay.
So, but that being said, if you would like to read the chapter on neural nets and then schedule some one-on-one time to troubleshoot it and answer questions about it, I would be more than happy to do that.
Okay.
But I do think that coming out of this, I want everyone in the class to have strong foundations so that you can continue to do learning. And I do think that neural nets, without the foundation, you're doing yourself a disservice if you dive into it.
I mean, it's like the machine learning models we've made. You kind of construct it yourself with the code, right?
And it's a much more powerful, but also, quite frankly, a much more sophisticated model than anything we've looked at up until this point. So. But again, big shout out to the textbook. He's got some strong materials to work from there. Okay. Well then, on that note, we are going to turn the page over to logistic regression and lesson 11. So up until now, I've only introduced you guys pretty much to two types of models. Linear regression for outcomes that were numbers or dollars or I'm not sure a few of the other things, mostly dollars to be honest. And then k nearest neighbors, which was the most simple of the classification models, either for binary or for multi-class, and we've seen a number of k and n examples. Tonight I'm going to introduce you to another classifier model that is similar to k and n because it can flag things as a yes, no, or as a 1, 2, 3, but it's actually much more powerful. It has typically a much higher accuracy than k and n. It's got a stronger theoretical grounding, and quite frankly, it is a go-to in my industry experience for any classification task. Logistic regression is always going to be a strong candidate for solving that. So I'm going to go ahead and walk us through some of the theory and a lot of the code, and by the end of tonight's class, you should be able to put together a simple classification model that uses logistic regression. Now I will say in the kind of the nuts and bolts of it, it will look quite similar to k and n in a number of ways. The biggest difference is when you instantiate the sklearn model. But under the hood, in terms of the theory, it's doing a number of things that are quite different from k-nearest neighbors. With KNN, the algorithm simply looks at the 5 most similar observations and averages them in order to make a prediction. So it's quite simplistic. With logistic regression, it analyzes the entire data set and uses the sum of least squares in order to predict the S-shaped curve, which will be the line of best fit. And then for every observation, determines how close it is to that line of best fit. So that's what we're going to take a look at tonight. As usual, we've got code and assets. We've got solution and starter code, but honestly, I think the starter code is identical to the solution code. It's already been filled in. But there is a folder called Extra Materials where I brought in a bunch of stuff from another class I taught at Deloitte. So it has maybe like 10 different examples of classification using logistic regression and a few other models as well. So this is like a freebie bonus of material that you could dig into. I think they're pretty well written. They've got some nice examples. We're just going to be digging into logistic, but there is a lot here for you to study on your own if the spirit moved you in that direction. There are 2 solution files, Titanic and a straight up logistic with a window data set. So I'm going to walk through both of these and then the last 20 minutes see if you can build one out on your own. So we are in lesson 11. In terms of code, I would like you to have open the solution code for number 1, logistic regression. And then I would also like you to have open a blank data file where we will be coding along. And here in Slack, just pound the squirrel when you are ready to go.
You said we're doing a solution code?
I am following the solution code, but I would like you to code in a blank notebook. I will wait until I get 7, 8 squirrels.
Do you use Bayesian a lot in your job? I saw that you had some Bayesian codes over there.
Not a lot, but whenever we build a classifier, we always compare 3 models: naive Bayes, logistic, and random forest. And we take a look at those 3 and we pick whichever of the 3 has the highest accuracy.
Okay.
I'm missing 2 more.
And you do the random forest because decision trees are not as comprehensive, although the concept is the same.
Yeah, decision trees are very prone to overfitting.
Yeah.
A random forest, which we'll see in a maybe Wednesday's class or next week, I will introduce you to random forest. There's a whole bunch of decision trees, but randomized so that they don't overfit so easily. And we are ready to go. Okay. So logistic regression is the title of our notebook. And we are going to call this logistic class notes. We're going to import pandas as PD. We're going to from. I guess we're going to do these imports as we go along. K-neighbors classifier. From sklearn neighbors import k neighbors classifier from sklearn dot linear model import linear regression, and from sklearn dot linear model import and then a few others here. Let's see here. Continuous phosphor. What am I doing wrong there? This may be an old import statement. Let's take a look here. Is there no underscore? Is that what it is? Thank you. Yep, thanks. Good day. Thank you. Okay, and then in addition to that, for visualization purposes, we will want to invoke import matplotlib.pyplot as plt, import Seaborn as SNS, and matplotlib inline, and probably numpy too. Import numpy as input. With that, I think we should be good to go on imports. And then we need to define our URL. So this is we're reading from an online data set. For this, I'm toggling over to the solution code here, and the column names as well. I'm just going to copy that part from the solution code. And while you copy that over, let me speak briefly about the data set. This is a data set, again, good for learning purposes because it has very strong, easy to predict statistical values. There's a high correlation between all the variables, and it's got a very clean classification between types. It's a data set of glass. What you want to predict is the type of glass, whether it's industrial or household. And all the other elements are like the periodic table of the elements. They're the components of the glass. Iron is Fe, aluminum is Al, barium is Ba, I forget what the other ones are, but these are basically the chemical elements that go into the glass in order to determine whether it's industrial or household. That's what we're going to try and predict. So we're going to call our data set glass. We're going to set it equal to pd.read CSV URL, where the names of the data set are equal to column names, and the index column is going to be equal to the ID column. And then we'll call glass.head, and it looks like this. Hopefully everybody gets the same. Oh no, RI is the predictor, that's right. We want to predict reflective index, RI. So if you look at RI, this is clearly a linear problem. This data set is designed for both linear and classification. So for a linear problem, your reflective index is a continuous variable. For classification, you look at glass type. And I think I'm going to skip some of this. There's a whole section here on linear regression, which is, I guess, a recap of what we saw last week. Quick recap of linear regression. sns.reg plot x equals aluminum and y is equal to reflective index, data is equal to glass, will show you that there is a pretty strong association. As the amount of aluminum goes down, then the degree of reflective index also tends to go down. You have less reflective glass. As aluminum goes up, then your reflective index also tends to go up. There's a strong correlation between the two. We would call this EDA. And we could also do glass.core, and we would see the full thing. Might call this correlations. Cores is equal to glass.core, and then call cores ri dot sort values. And we would see that, and I don't actually know what chemical element Ca is, but iron and barium also have a fairly high correlation between the two. But Ca clearly has a high correlation with reflective index, and so does aluminum and Si, which might be silver for all I know. But the ones in the middle, such as glass type or Mg, don't really have any correlation whatsoever with reflective index. This would help me choose the predictors to include in my model. If you could only pick 3 predictors for your model of Ri, what would they be based on this correlation? Definitely Ca, because that one's got a correlation of 81. What would be the other 2? Exactly, because even though they're negative, they're still large, like the absolute value is large. So those would be my 3 big predictors. I would say that as silver goes down, reflective index tends to go up, and same with aluminum.
What are the demerits not to include every predictor?
One more time, please.
What are the demerits? Why don't we include every possible predictor?
Oh, you can actually, and there's no harm in that. Except for glass type, you wouldn't really want to include glass type because it's not really continuous. But yeah, just throw them all in there. And the only serious problem with doing that is you potentially lead to overfitting, where your model is very good on predicting on your training data and not otherwise. But in fact, in my experience, you typically would just include all of them and that would be fine. But it is useful to know ahead of time kind of which predictors are most likely to present outcomes. Okay, so let's go ahead and build a regression model using the same steps we saw last week. So we would instantiate the sklearn class as follows. linreg, or actually I'm going to call it LR model. LR model for linear regression. No, actually, logistic regression also starts with LR. So how about lin model? There we go. Is equal to linear regression. And then you might, how far down into this do they go? I'm going to go off script a little bit and see what happens. Establish your target. So y is equal to glass Ri. Establish your predictors. X is going to be equal to glass.drop Ri and also, what's the other one? It was called glass type. So going with what Ayaka said, we're just going to keep everything.
Is that because we're predicting on Ri?
Exactly. Since you are actually predicting reflective index, you don't want to include it as a predictor. And I'm dropping glass type because it is a categorical variable. And I could convert it into a dummy, but I'm just going to drop it for simplicity's sake.
You just use fictional columns instead of dropping the columns, like choose the salient columns we can use here.
Yes, you could have also done this. It's equal to, and then I would have to figure out what they are. And I would go up here and maybe grab all of these bad boys right here. But keep in mind that you would have to use a double bracket. Drop that in, and then for each of these, I don't know if everybody was able to hear Yalden's question, but basically cell 14 and cell 15 are doing exactly the same thing in different ways. So as long as you're aware of that, I think that cell 14 is slightly more efficient in terms of code, but there's actually going to be no difference in the results. Okay. What's the next step? Who can tell me?
Fit.
No.
We take train.
Exactly, train test split.
Then fit.
I'm actually copying it just to make sure I don't screw it up this time. Because you guys, I don't know, you make me nervous or something. I don't know what it is. I mess it up every time. I'm so shy in front of you. Test. Split. And I want to put in here x, y, random state is equal to, see if the Nats can win tonight. Tonight is game 4.
That'd be bad news.
I know, I'm not feeling it, but who knows? Maybe Max can pull it out of the bag still. And random state, and what am I missing here? Test size, of course, is equal to 0.3. Oh, we never imported our train test split, of course. From sklearn dot. Okay. And then the next step after that, Alex said it earlier. Can somebody else remind me what he said?
Fit the training data.
Fit.
the model to the training data.
Yes, fit the model on the training data, or to the training data is fine. So we have a trained model, and our model is called lin model.fit xtrain ytrain. And of course, once you fit on the training data, you do what to the testing data? You predict, yes. So we want to define ypreds as equal to lin model dot predict y test x test, of course. And I have a typo. There we go. This is a me thing. Not everybody does this, but I always like to check out the first 5. Just to make sure it passes the smell test, right? Maybe I'll print those. I'll also print the first 5 for the y test. Return them into a list. And 516, 7. This is so close that I feel like that I'd miss a step. It is unusually accurate.
It's okay, let me skip this.
Well, let's see how far we get with the predictions. I'm actually not following the solution code for this because they only have one predictor. So let's see where we go with this, okay? Check out the first 5, and then we would want to evaluate, which is actually a whole new step. So from sklearn import metrics, and I sure can.
Yeah.
Sorry. Pause there for a second. So we want to start with RMSE. RMSE is going to be equal to, that's the root mean squared error, is the square root of metrics.mean squared error between y-test and y-preds. And that's NP square root. And then print RMSE. And that's actually a very, very low RMSE, which means that our model is extremely accurate. And that may be why they chose this, because once you know the composition of the glass, it's really easy to predict the reflective index. That's actually why, just as a side note, sklearn comes with a number of built-in data sets for training purposes, and they choose them because they're really easy to predict with. So my guess is that's what's going on
Did you
here.
import NumPy at some point?
I did.
Donde? Where?
I went back and I fixed my code, so you
Okay.
might have missed it. But just import NumPy as NP, right?
No, I didn't. I don't think you did.
I missed it and then went back and fixed it. And in addition to that, in addition to root mean squared error, which I will put in here as a note, root mean squared error uses the same metric as our outcome. So if reflective index is measured in centimeters, then this also is measured in centimeters, and our model is off by a fraction of a thousandth of a centimeter, which means it's highly accurate. Or the R squared measures the amount of variance explained in the outcome. So for this one, we'd say R squared is equal to metrics dot R2 score, y-test, y-preds, and of course print it. It ranges from 0 to 100. We have an R squared of 91%, which means that our model fails to explain only 9% of the variability in the outcome. That's pretty good.
That's winning, right?
Yeah,
That's winning.
that's winning. And finally, scatter plot is a nice way to compare. Let's do plot figure of fig size equal to 6 and 6. And we'll do sns.regplot because it has the built-in line. X is equal to y-pred and y is equal to y-test. Y-preds, of course. And wow, look at that. That's a really tight line. Our predictions cluster very tightly with the true values, with the exception of a few outliers. Scroll back up to the code. So all of that should be kind of a recap of what we saw last week with the NBA players and the baseball stats and all that. One thing, of course, that we did not discuss, but it is useful to know, is linear regression has coefficients. And sometimes you want to look at these to find out which features are most important to your model. Our model was called linModel, and it has functions like .fit or .predict that we've seen up until now, but it has another one called .coefficients. And when you run this, it gives you 8 coefficients because there are 8 predictors in my model. That corresponds to x.columns. So NA has a coefficient of 1.13. MG has a coefficient of 1.57, etc. What we would interpret this to mean, so let me see if I can do this. List, zip, list, and list subcolumns. Let's see if that works. It did. Nice. Turn all that into a data frame. And let's actually do this after. This is how to make your regression results look tidy. Let's do zip. There we go. Names is equal to pred coef Okay, fine. So anyway, the point here is that how would we interpret the number -0001 for aluminum? What this means is as the amount of aluminum increases by 1 gram, the reflective index decreases by 0.0001. As the amount of iron increases by 1 gram, the reflective index decreases by 0.0001. So this allows you to see which of your predictors has the biggest impact on your outcome. But let's pivot now. What if we wanted to classify instead of linear regression? So let's take a look at our glass data set. And glass type, over at the far right-hand side, is a categorical variable. Let's check out its values. Class dot glass type dot value counts shows us that there are 6 possible glass types. And we can do sort index in order to get them in the right order. There we go. Ranging from glass type number 1, which I believe is the most industrial, to glass type number 7, which if I remember is the most household style glass. So what if we wanted to predict based on chemical elements, similar to what we just did with reflective index? First, let's create a binary variable for household glass. Using the map function, we're going to create a new variable called household, and it's going to be equal to glass type, but we're simply going to map values into 0s and 1s using .map. And this is a dictionary. If it's a 1, it becomes a 0. If it's 2, it becomes a 0. If it's 3, it becomes a 0. But if it's 5, it becomes a 1. 6 becomes a 1, and 7 becomes a 1. And then we call the value counts on that. And we can see that there are 166 rows of industrial glass and 51 of household glass. Let's predict that. So we could use linear regression in order to do that. And that would actually work. It's not unreasonable. I'm going to go ahead and I'm going to copy all the code from the previous cells. Let's see here. All of these cells, I'm just copying them. And I'm pasting them down here. And let's group that into a single row. Value count. So we've got linear regression. We're going to establish our target. We're going to establish our predictors. That one I don't need. We'll bring in our train test split. And fit on the training data. And we're going to predict on the testing data. And then we check out the first 5, and we'll see how this works. I'm just going to get rid of all the other cells.
Did you consider copying that into
Slack?
file?
Here it comes. Quick summary. So that was for the linear regression. The only thing that we need to switch here, we need to switch out a few things. Instead of linear regression, it's going to be logistic regression. So we're going to call this one log model. Instead of it being glass RI, we're going to predict glass household. We'll keep reflective index this time as a predictor, but we'll ditch glass type. This becomes log reg. This becomes log reg. And I think the rest remains exactly the same. So let's go ahead and run that. And look at that. Our first 5 predictions are 0, 1, 0, 0, 0. And the true values are also 0, 1, 0, 0, and 0. So it looks like our linear regression model did an okay job. We could also use the same evaluation metrics that we used earlier, which was up here. And I think that that was these 3 guys here, which I'll copy down. Paste them here. Paste. Oh, grab the wrong one. Evaluation. Here we go.
You need to put that as well, Seth?
I don't need to re-import it, no. I already imported it the one time. Paste. Kind of scrunch all this into a single cell. Scatter plot. Delete. Delete that. Print. And here we go. We have a root mean squared error of 0.24. We have an R squared of 0.69. And we have some metrics that are pretty tough to interpret because there are just 4 points of data, 1 and 1, 0 and 0. So though our predictive code worked pretty well, in fact, our solution code does not work well at all. I'm going to go ahead and slack this out. Our evaluation code. Evaluation code looks like this. And what this means is we need a different set of evaluators for logistic regression and classification generally. And we saw this earlier with KNN when we looked at the confusion matrix. Evaluate your classifier using the correct metrics. So the first thing I'd like to take a look at is the accuracy score. And this is, of course, y-preds and actually y-test comes first, y-test and then y-preds. We have an accuracy of 93%. That's pretty good. We have a metrics dot confusion matrix, once again of y-test and y-preds. And we can see on the diagonal 46 and 15 versus 1 and 3. Once again, we're predicting pretty well. When it's a 0, we said it was a 0. When it was a 1, we said it was a 1. There's a third metric, which is very popular, called the F1 score, which is a little bit more robust than accuracy. Accuracy can be quite misleading when you have imbalanced classes. Like when you're predicting cancer and you test 1,000 patients and only one of them has cancer, and your algorithm is the following: you don't have cancer. Your model will be accurate 99.9% of the time, right? It's a really high accuracy score, and the reason why is because your testing data is so imbalanced. F1 scores account for that. They take into consideration the number of true versus false values. So notice that our F1 score is actually a bit lower, but probably more meaningful than our accuracy score. Yeah.
Which ones did you drop the median or distribution? Which ones did you drop RI last day and syllabus?
Let me go back and take a look. Looks like I dropped household and glass type, but I kept RI on purpose because it's actually a meaningful predictor.
I have a classification matrix and a mix of binary continuous targets, so it's missing.
Oh, which cell was that on?
Accuracy.
And the same thing.
On 50.
Right.
You got an error score.
Mm-hmm.
What does it say again?
Classification metrics can handle a mix of binary continuous targets.
Is it possible you're running that on the linear model instead of the logistic model? Yeah, that's what I would have expected if you had a continuous outcome.
I have the same thing.
I copied the evaluation metrics.
Right, but up here in the
The recording 01.
in this section here, did you follow all of these steps?
Yeah, I changed the household last time.
Did you
Fixed
did you?
the-
That's one.
That's the
Even
one.
though-
Yep,
Yeah.
logistics regression.
Yeah, that's probably what it is.
Don't forget to change the model that you instantiate.
Exactly. Okay.
So
Yes.
to decide what evaluation methods to use or what evaluation methods to use,
Yes.
we should focus on the target, whether it's categorical or
Continuous. Exactly.
it depends on the target.
It definitely depends on the target. If it is a continuous variable, then you would want to look at these three: root mean squared error, R squared, and the scatter plot of predictions. If it's categorical, then you would want to look at the confusion matrix, the accuracy score, or the F1 score. And there's a third one called the ROC-OC score, and I think I'll end with this before I break, because I'm pretty sure they have ROC-OC in here. Looks like they have it in the, all right, then I'll say there's another one, but I'll save it for a little later on when I have the code at my fingertips. For right now, just to understand that your accuracy, this means that your model gets it right 93% of the time. And in terms of the F1 score, your model gets it right 88% of the time, accounting for the fact that there is an imbalance between true and false positives. And of course, the last step would be to pickle your model and make new predictions, right, on new data. And this is where your Jupyter Notebook would stop and your app.py would start. I am looking for operations. Let's try this one. There we go, that's what I'm looking for. Import pickle. Open your file. File is equal to open, and we're going to call this my logistic model.pkl. We're going to write bytes to it, and we'll do pickle dump. And the thing that we're going to dump is our log model. We're going to dump it into file, and then you want to do file.post. And once you do this, you'll see it saved in the same directory where your Jupyter Notebook is running. Let's pretend we're now in app.py. Here you can Let's see here. File is equal to open, exactly the same name, mylogisticmodel.pickle. So we're going to open up our pickle file. But this time, instead of write bytes, we're going to read bytes. You want to call my model is equal to pickle.load file, and then file.close. And once you do that, you can do my model.predict on whatever your new data is, which we would have to define. So to define new data, let's make up some new data. I'd probably want to take a look at my x.loc. Let's take a look at one row of data. Looks like this. We'll turn it into a list.
Awesome.
Yeah.
I remember if the advantage to do this is that you have need to import maybe the schema and stuff. You have that by.
Exactly. Well, there's a number of advantages. One is that you don't have to do any imports, but the other is you don't have to retrain your model inside of app.py. You want to train your model once and then predict multiple times.
What's RB and WB means?
WB means write bytes, and RB means read bytes. It's simply telling Python whether it should be writing or reading information from the file. So our fake data is this. We're going to define this as new data is equal to, notice that it has to be a list inside of a list, and now based on that information, it's predicting that that new information is not household glass, it's industrial. And that would be what would be happening inside of app.py. App.py would load the trained model, would read in new data, potentially given by a user, and make a prediction, predicting it to be a 0 or 1 in terms of household. It's actually pretty similar to what we did with k-nearest neighbors last time around. But this part here, this last step, is what, frankly, they never taught me when I was doing my data science classes. Everything always ended with predicting on testing data. I was like, that's cool and all. You can work on this all weekend long until you get a really high accuracy score, but what good is that? You already know the values of your testing data. Well, the good is when you can then give it to an end user and they can start making their own predictions based on your trained model. And that's what pickling and the Plotly Dash app is all about. Okay.
So here the list x.log actually is like rendering final data in the past list.
I didn't follow, I'm sorry.
Like the list x.log here, it's like randomly choose the data from the past data.
This list right here called new data. Is that the list?
No, the last. I mean,
Give me a cell number.
The 56.
56. This guy. I did that because I could have just pulled numbers out of my sleeve, but I wanted them to be similar to the actual data set. So I actually took one row of the real data set, but if I wanted to, I could have made some tweaks, right? Instead of 1.5, I could have said 1.6, 13.2, right? Now I'm faking it, so it's similar, but still reasonable. You see what I'm getting at? And it's still 0. I'll bet if I start making some of these really outrageously big, I can make it become a 1. What do you think? That's what 45 and
for the cell 56 to pull out some random data.
yeah. Okay, well, look, let's go ahead and break. 13 minutes. We'll come back at 8:20, and we'll do this all over again with the Titanic data. Okay.
Yeah, listen, I got an error.
Let me take a look.
It says log model not defined.
Here I come. Log model is not defined. Did you name yours log model? What did you name yours? Scroll. Let's see. Here's this one called Lin model. Your Lin model, so Lin and log is just linear versus yeah.
What do you mean?
Follow first.
Yes.
Yeah, you can have it done.
No, but
Go ahead.
didn't follow the middle one. And after the strawberry.
What?
Nothing. How are you?
I'm like,
So here's my problem. Come take a look.
already? You think I can solve it?
You say you're an expert.
I never said that.
What? You solved the problem. I saw your app that you created.
That's the very. What kind of app?
The one that you're digging at.
Oh, that's not an app. It's either.
Yeah.
I just threw some explorer regarding
I hope that's true. Maybe you've seen it before.
Don't.
But the cool thing, which is forcing me. If not, I would have done some mute. So I'm actually modeling last night or the day before, and it's just forcing me to probably change my data.
I think maybe over has to be like capability, but anyway, I'm going to pass it.
Where you going? Where are you going?
That's true.
No. I follow.
No, if I have
Jesus.
no, it's already.
I could see the game. The basketball game kind of
Okay, it's
shit.
just
I'm kidding.
you cannot see.
I'm messing with you. I'm giving
It's
you
a
a hard,
law. It's a.
I'm giving you a hard time.
You
Relax.
cannot see. What? It didn't follow.
So also there was one more thing I wanted to do. So if you look at the headers here, and what I did here, this does work. When I do this, he actually formats and puts the ticker. What I wanted to do here, you see where we have the index as the date, I also wanted to put the ticker for each column.
You want to have a new column that is the ticker of the column.
Yeah.
Right?
Okay. So I'm gonna add a new column, right? I'm gonna make a ticker equals ticker, because the ticker comes from that format.
So where is the ticker information saved?
Probably right over
To
there.
the name of the file.
Yep. Is the name of the file itself.
Okay.
But the name of the file, I don't want it to come with the extension as well.
So toggle over to Slack for a second. Let's take a look at the code that it's in. I had a similar issue with my Reddit data. Okay, so in this, can you make this a little wider so it's on some point? So in this information, every file name, I wanted to save the name of the file as a new column. So at the third line, small df source is equal to string file, where file is the name of the file.
Okay.
And this creates a column where every row is simply the name of the input.
But it will not be the.
And I assume that the name of the file is probably the ticker, right?
It is.
Yeah. So do that, and then just remove use a string.split to remove the .csv or something.
Yep, that's okay. So I already did that before. So that's it. Okay, that is the only way.
Well, it's not. There's always lots of ways.
So
to
yeah,
do it. So that is a way to do it.
So yeah, each file has that. So we're gonna open it.
Right. It's phm.csv, right?
That's the input that it is.
Yeah. So just set the name of the file equal to the value of the new column. Yeah.
I have a question.
Sure.
So for the figure we talked about Slack and
This is going to send me in Slack, right?
Yeah.
This is a plotted figure, isn't it?
no, it's a math.
Go back to it. That looks to me like a plotted figure. You imported Matplotlib, but you used
Yeah.
Plotly in order to create that figure.
So for this one, what should I do? Save
You want to save it as a JPEG.
or PNG?
Well, let me ask this: why do you want to do that?
Because I tried to screenshot it for my PowerPoint and it's too blurred for.
So if you really want a screenshot, you shouldn't be using Plotly, because Plotly is made for bigger things than that. You would be better off generating this with Matplotlib.
Okay.
But if you really, really have to, Plotly does actually have an export to static, which you can Google it.
Okay.
And I used it the other day and felt ashamed after doing so. Export to static image. Static image export, here we go. Right. Looks like you have to install a new dependency in order to make it happen. And then you write an image file. So let me send this to you,
Boy, he's
and it
smiling.
should give you what you need, okay?
Boy, he's smiling.
Questions at Yalvin?
I do it. What are you looking
Great. Thank you very much.
You got it.
for? What?
When we
Oh,